Hello statistics student, this video is for chapter 2.7. We're still on the use of standard deviation, and we introduce some new terms and also some application of standard deviation in analyzing data. So the first concept we want to cover is called C-score. So C-score is a number without units, so it's can be 1, 2, 3, -1, -2, -3. It is used to describe how far away a value is from the mean. So I think I talked about this before. After we calculate standard deviation, we basically say the mean. So if this is all the x values, the value of the data, so they would be like in different place, right on the number line. But we say we can divide the number line by using tick mark. And each tick mark is one standard deviation, right? This is plus 1 SD. This would be plus 2 SD from the mean. This tick mark is minus 1 SD. This tick mark is minus 2 SD. So the number, the position of every data has its value, of course, but you can also describe its value by how many standard deviation it is from the mean. Okay, so sample data can be is from the mean, but how many times of a standard deviation? So if I am half standard deviation from the mean, I can say my number is the mean plus the standard deviation size and the number of standard deviation. So if my data is here, which is say for example 1.4 times of standard deviation, so you will say my data is the mean at 1.4 of standard deviation, right? So this number that tells how many times, how many tick marks it is. So it's 1.4 tick mark. That is the C-score. So C-score is the number of standard deviation a data value x is from the mean. And the way you calculate it is, of course, the data value x. Okay. So the data value x, you subtract it from the mean. So you find out how far away it is from the mean. So if I'm going to graph it over here again. So this is the mean. In case it's population data is mu, in case it's sample is x bar. And so these are the standard deviation marking. 1 standard deviation, 2 standard deviation. So if your number is like here, 1.4, then how do you find this 1.4? You would have your data value x, right? You subtract it from the mean so you know how far they are from each other. And then you divide it by sigma because each one is a sigma. So you divide it by sigma. So x, the value minus mu divided by sigma. Mu is mean. Sigma is the population standard deviation if we have population data. And if we have sample data, we can use this. And sometimes we can actually, if we know the mean and standard deviation, we can actually use them. So this is not just for if X is a population data. So what is the round-off rule? The round-off rule traditionally is 2 decimal places. And remember, Z, it just tells you how many tick mark it is. So it has no units. Z-score tells how many standard deviation a value is from the mean. Negative Z-score, I should say, means the X value is below the mean. Positive Z-score, I think it is not very. Positive Z-score means the X is above the mean. And Z-score has no unit. It just tells you how many tick marks. So for example, I have a student's English score is 80, but the class mean is, the student score is 83, but the class mean is 80. So I'm going to draw the number line. This is the mean of the whole class is 80. The standard deviation is 10, so that means 90 is 1 standard deviation, 100 is 2 standard deviation above the mean, 70 is 1 standard deviation below the mean, 60 is 2 standard deviation below the mean. So we say the student has an 83, so it will be here, right? How far away is it from the mean? It is 3 from the mean, but what is the size of the standard deviation? The size of the standard deviation is 10. So we would calculate 83 minus 80 over 10, that's 0.3. So this is the English z-score. Its position on the English data line is 0.3. So if someone tells me, oh, that your z-score is 0.3, you know that you are 0.3 times of a standard deviation above the mean. You're not 0.3 score above the mean. It's 0.3 times of the standard deviation. If the standard deviation is 1 tick mark, you are 0.3 tick mark, right? And then history, this person scored 75, but the mean is 72, so it's still 3 points above, but you can do history here. The mean is 72. So each tick mark is 7 though, right? So this is 7. So one standard deviation is 79. Do you agree? Another standard deviation is 7. 79 plus 7 is 86 only. And if I want to do the negative, 72 minus 7 is 65. And minus 7 again is what? 65 minus 7 is 58. Right? But this person's score is, this is X. The student's score, English history score is 75. So we put it here, but where should I put it? 7. So this is 3 away from 72. But I should put it right, almost in the middle, right? Because 3 away out of 7 is 0.43. So we would say the history z-score is 0.43. English z-score is 0.3. And technically speaking, do the students score better in English or history? They're more or less the same, but in history has a higher z-score, right? 0.43 is greater than 0.3, so better in history because it's higher. When you score something, you want to score a higher z-score. So you can see if the standard deviation change, it affects your z-score. So the student scores less than 1 standard deviation for both, but 0.43 is greater than 0.3, so the students score better in histories. The other use of z-score, so remember, z-score is what is your tick mark? If someone say, instead of percentile, they tells you that, oh, your z-score is 1.2. That means, oh, you're 1.2 times of standard deviation above the mean. And if you are 2 standard deviation above the mean, that's exceptionally good, right? Because most data are 2 standard deviation above or below the mean. The next things we want to talk about is something called empirical rule. This is it's the use of a z-score to actually find about what percentage of the data is within a range of the value. If I have a distribution that is bell-shaped and symmetric, okay, so this apply the empirical rule apply to distribution that's bell-shaped and symmetric, and sometimes we call it normal distribution. Another term for bell-shaped and symmetric is normal. Then we have these facts that statistician has found. That we understand that most of the time most of the data is spread around the mean, right? So this is x bar or mu, right? And then this would be 1 standard deviation away plus 1 SD plus S plus minus 1 S, this is minus S, and then plus another S, 2S, minus 2S, or plus sigma plus 2 sigma. Oopsie, it's too close to the boundary. Plus 2 sigma and minus 2 sigma. So it depends on if you have sigma or the sample standard deviation. So what happened is they find that the percentage of data within 1 standard deviation from the mean is 68%. So these lists of data, so this, if you calculate the number from here, this range to this range, it would be 68%. Similar to the quartile, right? So for quartile is 25, 25, 25. But for if it is bell-shaped and if they are, we calculate the standard deviation, it's better. The middle is 65% because data are like bell-shaped. So the more data cluster around in a histogram, you see a high peak around in the first standard deviation area. So that's 68%. And then what about 2 standard deviation away? 2 standard deviation away is these two here. So the bigger range. It turns out that we say most of the data are within 2 standard deviation away. This is the one of the number that you can see that it makes sense because 95% of all data are within 2 standard deviation away from the mean. From negative 2 sigma to plus 2 sigma, this range is 95%. And then of course we have 3 standard deviation. So if you do one more tick mark here, 3 standard deviation plus and minus, that's 99.7% of all data, almost all data are within 3 standard deviation away. So the books use this diagram. So you would have 1 standard deviation 68, 2 standard deviation 95, 3 standard deviation 99.7. So these are pre-calculated already and you just use it. So do an example. We know the distribution of daily cash withdrawal from an ATM machine is bell-shaped, normal distribution. The mean is 42 and the standard deviation is 6. Typically, they will tell you, oh, a lot of people draw cash from it. Some people draw more. Some people draw less. Sometimes you get $40. Sometimes you take $60. Sometimes, do you ever take $20? What? So, but it could happen, right? So if you don't have money, you would take $20 and a standard deviation of $6. So it is a particular ATM machine's case, not for in general. So use the empirical rule to calculate the percentage of cash withdrawals that falls between 30 to 54. We don't know what to do. So what we can do is just draw the number line. Use the mean and standard deviation. So the mean is 42. Standard deviation is 6. So you add 6, right? Add 6, that would be 48. Add 6 again, because this is standard deviation of 48 plus 50. So that's 54. Then on this side, you minus 6. So that would be 36. Oh, you minus 6. Again, it's 30. We should do one more, right? So this would be one more. Minus 6 again is 24. Plus 6 again, 54. Oh, that's 60. Now, we want to know what percentage fall between 30 to 54. Oh, 54 falls here, right? 30 falls here. How many are they from the mean? This is 2 tick marks, so 2 standard deviation. This is the other side is also 2 tick marks, so there are 2 SD below and 2 SD above. And what do we say in the empirical rule? The empirical rule say if this is within 2 standard deviations from the mean, it's 95%. So match that with the tick marks and you would say, oh, that is equal to 95%. So that is your answer. So 95% cash withdrawal will be between $30 to $54. B, what percent of cash withdrawal fall between 24 to 60? So you look at your tick mark. So they always ask for this new good number. So 24 is here, right? How many times is it away from 60 is here? It's 3 tick mark. Do you see? 1, 2, 3, 3 below. 1, 2, 3, 3 above. So it's 3 standard deviation from both sides, right? So according to the empirical rule is 99.7%. So that's what you need to answer. They don't check you for number in between. They won't ask you though. What is the percent of cash that's between 32 to 49 like that? You will learn how to do those. That is in between standard deviations in chapter 6, I guess. Chapter 6 we'll talk about how to find those. But for the time being, you can tell that 1 standard deviation, 2 standard deviation, and 3 standard deviation, if they are bell-shaped, they obey the empirical rule.